What's going on, ladies and gents? Mr. D'Souza here. Hopefully you had a great amnesty week. I hope that you made up all the work for all your classes. We just want to see you successful. So for the remaining weeks that we have together, we're kind of going to go back so that you can move forward. We are going to be preparing you for Algebra 2. All of you are going to be taking Algebra 2. So over the next weeks that we have left, we're still going to be learning geometry stuff, but I'm going to be emphasizing a lot of solving equations, how do numbers work, manipulating equations. Really, I don't want to call them basics, but it's really the fundamentals of algebra that you really need to know to be successful in mathematics. Not just for Algebra 2, but for calculus, pre-calc, statistics, so on and so forth. So you might find some things in this lesson are going to be really, really, really easy, and some things that you may not have known. Or you might think that everything is super hard, or you might think that everything is super easy. But I want to start from here before I assume that you know or remember stuff from Algebra 1 or middle school, or even elementary school, but we'll get to that in a little bit. Alright, so remember there's going to be a password somewhere in this video. I'm going to say it. Okay, make sure you fill out that password form, and let's just jump into it. Alright, so really what this lesson is going to be about, I didn't really put an aim, because it's not really a lesson, it's kind of like a bunch of stuff that you should have learned, or you might not have learned 100%. So I'm just going to call this a crash course, algebra tips. Okay, so we're going to start off with a bunch of algebra facts that you may have remembered, and then we're going to work into solving equations later on in the lesson. Okay, so algebra tip number 1 is the commutative property. Now the commutative property says this, that if you have two terms, which we'll talk about what terms mean in a little bit, but for now let's just talk about numbers. If you have two numbers that are being multiplied together, you can rearrange the order. So 3 times 5 is the same thing as 5 times 3. Okay, or if you had addition, if you have 8 plus, let's say, negative 5, that's the same thing as negative 5 plus 8. The next property we're going to talk about is the distributive property. And now you probably 100% have seen this. Distributive property is if you have a coefficient to a bunch of terms, usually, actually all the time it's broken up by parentheses, you can distribute and you can multiply each term by the coefficient on the outside. So 4 times x is 4x, 4 times 2 is 8, and that's it. Or the other thing that we can talk about is factoring, which is essentially like the reverse distributive property, where we can pull out a common divisor, a common term. So like, for example, the biggest number I can pull out of both of these terms, and terms are just a group, I'll say it now, it's a group of either just numbers or numbers and variables broken up with the operation of multiplication, right? So you see how 8 times x squared, we assume that there's multiplication between. Anyways, so the biggest thing that I can pull out of both of these terms, 4 divides both of these numbers, and also they share one x in common. So 8 divided by 4 is 2. If I'm taking out one of the x's, I'm just left with x. If I'm pulling out 4 divided by 4 is 1. And if I'm pulling out an x, there's no x's left. Right? Now if I were to redistribute this, you get back to ax squared minus 4x. Again, things you definitely have seen before, but just reminding you how it works. All right, reflexive property of equality. Now, you might not have seen this term before. I know for geometry, we talk about the reflexive property. For example, if like 2 triangles share the same side, we say that's the reflexive property because it's the same thing equaling each other. Well, the reflexive property of equality is kind of similar. All this says is you can just flip an equal sign. So for example, this is the same thing as this. You can literally just flip it and it's the same. So more basic, if I said 2x equals 4, that's the same thing as 4 equals 2x. It's the same thing. It's just flipping the terms on the equal sign. Okay? That is generally helpful with actually what we're going to be doing next week, which is about volume and different formulas and all that kind of stuff. Because we're used to seeing the variables on one side. For example, this, what I circled, a lot of you would say, okay, I've seen something like that before. But if I showed you the thing on the bottom, you might be like, I don't know what that is because it looks a little bit different, but really it's the same thing. So if that bothers you, which sometimes it bothers me, I like to switch it so that my variables are on the left and everything else is on the right-hand side. All right, fractions. A lot of you I know are scared of fractions or think that fractions are hard. And I think the reason for that, because I also had that same feeling when I was in school. People have these feelings because they're actually not taught like why fractions work, right? People are afraid of decimals for some reason, but decimals are numbers. Fractions are just numbers. They just look a little bit different. And I'm a strong believer that if you learn how to use a fraction, like how to multiply, how to add, all those kinds of things, how do fractions actually work, and then you practice those skills, I will tell you that it makes life so much easier, just crazy easier, when you're working with fractions. Okay. Now, yes, you might have a calculator, or you can use your phone as a calculator. But I am a strong believer that if you just understand like how fractions work, you get less intimidated when you get something that has a bunch of fractions in it. Okay. So a couple of things. So you definitely learned in elementary school and probably middle school this symbol. We don't use this symbol in real mathematics. I shouldn't say real. In mathematics that you learned, that specifically you learn in like college and stuff like that, you don't use this symbol mainly because this symbol is extraordinarily confusing. Like you've seen this probably stuff on like Facebook or whatever y'all are on, where they have like a long equation, they have a bunch of division signs just like that, and it's like, oh, what's the answer? The reason why those are always on Instagram and Facebook is because it is very confusing to understand the order of operations when you use this symbol. So I want to tell you that fractions is literally just dividing two numbers. So, for example, 1 divided by 2, this is the same thing as 1/2. This sign, this bar, is division. It's 1 divided by 2, right? Or the same thing if I did 3 divided by 4, that's the same as 3/4. It's the same thing. 3 divided by 4 or 3/4, it's the same thing. And you'll notice, fun fact, that this division sign kind of looks like this, right? So it's kind of like you have your bar, and the dot on the top is the first number, and the dot on the bottom is the number on the right. So it kind of looks like that, where it's kind of like a division symbol. And definitely in elementary school, it's a lot easier for younger children to understand, like, oh, this symbol means this. But when it comes to higher level mathematics, it's a lot neater, and it makes a lot more sense when you use this notation, which is just the bar. Now, you're going to notice I'm going to skip adding and subtracting fractions. That might be in a later video, but I think it's beneficial for you to learn how to multiply fractions. It's a lot easier. It's a little bit more intuitive. Multiplying fractions, you multiply both the numerator, those are the numbers on the top, and you just multiply the denominators and simplify. So let's do that. 8 times 2 is 16. 3 times 2 is 6. Simplify this, which means that I can find numbers that divide both the top and bottom. So the biggest number I can think of is, let's just use 2 and see what happens. 16 divided by 2 is 8. 6 divided by 2 is 3. I can't find any number besides 1 that divides 8 and 3, so this must be my final answer. Now, Some of you might be like, Mr. D'Souza, this is mad easy. Let me show you something else. Okay? Let me show you something a little bit more rigorous. All right, so another way you can do this is I'm going to do the same thing. I'm just going to make it a little bit different. So 2 times 8, I'm going to write that as 2 times 8. 3 times 2, I'm going to write it as 3 times 2. Now, when you're dividing and your terms are separated by multiplication, you can divide out those terms. So for example, I can rewrite this as, okay, that's the commutative property, I can do that. And then, since this is broken up by multiplication, I can actually rewrite it like this. And you might be like, oh, 2 divided by 2 is 1. 8 divided by 3, I can't simplify that, so I got it as 8 divided by 3. 1 times 8 divided by 3 is just 8 divided by 3, and that's my answer. Now, that's the mathematical way of why it works. You might have seen a teacher, oh, I'm lagging, my bad. You might have seen a teacher be like, oh, yeah, you can just cross these out. Boom, and you're just left with 8 divided by 3. Very true. But a lot of teachers don't explain why you cross things out, and the reason why you cross things out is because of all of this work that we just did. I'm lagging so much. Okay? I would like to do another example, just so that you can kind of see how this works. Okay, so let's do this. Now, we could multiply straight across, and you get 24 over 20, and then you can reduce. Or you can do it my way. And eventually, with enough practice, you will do this in your head. You can rewrite it as 3 times 8, 4 times 5. Because these terms are separated by multiplication, see if any of them divide into each other. So does 4 go into 3? No. Does 4 go into 8? Yeah. 8 divided by 4 is 2. So I could rewrite this as 3 times 8 divided by 4 is 2. So 2 over 5. So this goes into this 2 times. 5 doesn't go into 3, so I got to leave it as this. And then 3 times 2 is 6. And you're left with 5 on the bottom. Now, if we did this the normal way, like I said before, 8 times 3 is 24. 5 times 4 is 20. And then we can divide both top and bottom by the biggest number that we can think of that divides both of them, which is 4. So 24 divided by 4 is 6. And 20 divided by 4 is 5. Now you might ask yourself, Mr. D'Souza, but I can just use my calculator. True. However, if you don't have this calculator right now, you're going to get a decimal on your phone. Unless you did something special on your phone that gets you this calculator, then that's awesome. However, you're going to see later in this lesson, when we start doing solving equations in a little bit, that when you just know these facts and you are very fluent in understanding how fractions work, and if things are separated by multiplication, you can simplify before you do anything, so on and so forth. It makes it a lot easier to solve basic problems. I'm going to be very transparent, right? A lot of things, especially when you're in Algebra 2, things usually boil down to solving an equation or solving some type of equation using some kind of method. And you don't want fractions to hold you back, right? So we're going to have a lot of practice with this. All right, so fun fact. If you didn't know this already, this may blow your mind. If not, it blew my mind and it makes things a lot interesting. Dividing is just multiplying by a fraction. I want you to think about that for a second. When you divide two numbers, it's the same thing as multiplying fractions. So for example, if I had, let's say I had 3 divided by 2. Did you know that this is the same thing as 3 times 1/2? Now you might ask yourself, well, Mr. D'Souza, How did you do that? That doesn't make sense. Well, remember, all whole numbers can be divided by 1, right? 3 divided by 1 is 3, nothing changes. If I multiply these two fractions, 3 times 1 is 3, 1 times 2 is 2. So if I had something like this is the same thing as me doing this. 2 over 4 times x. Right? Think about it. This is still technically x over 1. 2 times x is 2x. 4 times 1 is 4. But I can even go further. And we already should know this because these things are because the operation between 2 and x is multiplication. 2 divided by 4, that can be reduced to 1/2. Right? I'm going to leave the x on top. I can rewrite this because anything that has a 1 as a coefficient, you can just leave it by itself. And this is the same thing as this. Now, yes, I am going fast, and that's the purpose, right? A lot of these things you should have seen before, and I'm not trying to waste time kind of making like, oh, did you know this? And, taking a million years to really, really, really go in depth with a bunch of examples. But I want to just I kind of just want to give you like little appetizers of things that you may not have seen in algebra or may not have seen in like middle school that are just helpful tips. So when we go through the other lessons later, like next week and the week after, I'm going to highlight a lot of these tips because I think once you learn these little algebra facts, it makes doing a lot of harder things just very easy. All right, and I kind of already showed you this. This is a very common thing. If I wanted to multiply this, I already said this is technically over 1. So 4 times 1 is 4. 2 times 1 is 2. 4 divided by 2 is 2. Well, you don't always have to put the whole number over 1. You can kind of like remember that it is over 1. So a whole number, you just multiply by the top number. 8 times 2 is 16. And then remember, this is technically divided by 1. So 7 times 1 is 7. You just keep the number. That can't be reduced. We're done. So what if I wanted to do something a little bit more complicated? This is something that you're going to see. Okay, this is something that you're going to see. So this is the distributive property. So we know we're going to multiply. Okay. Now, you might be saying, OMG, like it's 3/2 or 3 over 2. I don't know how to multiply this. It's okay. X is technically a number that's in a numerator, right? When you're multiplying 3/2 times x, you're just multiplying the number, you're just multiplying the number on top. 3 times x is 3x. I'm going to leave the 2. I'm going to keep my negative sign. Similarly, 4 times 3/2, you can do it the same way. You could do 4 times 3, which is 12, then 12 divided by 2, and you'll get your answer. Or you can see, this is like the advanced way of thinking, this is the same thing as 3 times 4 divided by 2. 2 goes into 4 2 times, so I can rewrite this as 3x divided by 2 minus 2 goes into 4 2 times. 3 times 2 is 6. I'm just going to leave it as that for now. We could combine that, but I'm not trying to do that right now. Or you could have just done 4 times 3 is 12. 12 divided by 2 is 6, and you get the same answer. Okay? Now, I'm going to say this, and I'm going to have this in big letters on my screen. If you didn't learn these things in the past, this is going to seem very challenging. Being very honest, if you did not see any of these, specifically the fraction stuff, this is going to seem very challenging. And that's okay. Don't be overwhelmed. However, if you're not understanding and you need help, come to office hours. You have to come to office hours. You have to come to office hours. You have to come to office hours. Or email us. You gotta do those things. The only way that you get better at mathematics is, 1, by making mistakes, The only way to move forward, in my opinion, or to really understand mathematics, is making a mistake, learning why you made that mistake, and then learning the correct way. But the only way that you could make mistakes is you need to practice. If you don't practice, you're not teaching yourself the skills to learn all of these things, right? And again, these are just a couple of facts. There's so many more things. But again, if you need help, you have to come to office hours. You gotta, right? That's why we're here for. We want to help. All right, so this is kind of halfway through the lesson. Take a break, get a snack, and then just come on back, and we'll do the rest of the lesson. I'll see you in a little bit.